Now that we've determined the phase of the low frequency signal and the amplitude of the high frequency signal, let's figure out if they're related. As with the previous steps, we have at our disposal a variety of procedures to assess this relationship. Let's consider one here. To start, let's define the two-column phase amplitude vector. In this vector, phi is the phase of the low frequency band activity at some time index, and A is the amplitude of the high frequency band activity at the same time index. In other words, each row defines the instantaneous phase and amplitude of the low and high frequency filtered data, respectively. Let's now use this two-column vector to assess whether the phase and amplitude envelope are related. To begin, let's plot the average amplitude versus phase. To do this, let's divide the phase interval into bins of size 0.1, beginning at -pi and ending at pi. The choice of bin size is somewhat arbitrary. This choice is going to work fine for us, but you might consider the impact of other choices. For a given phase bin, we'll then determine the time indices where the phase phi falls within this phase bin. We can think of these times as indexing specific rows of the two-column phase amplitude vector. We'll then compute the average amplitude at these same time indices. The result is the average amplitude for phases that lie within the chosen phase bin. We'll repeat this procedure over and over for all phase bins.